In this video, we'll look at the concepts of permutations and combinations. We'll start with permutations. This is something that I found that students often get confused about. But again, it's not a hard concept. It's just something that you're learning for the first time. It's new, so it might be confusing. But as you get used to it, it becomes easier and easier. What is permutations? Permutations is the number of ways of choosing an ordered list of R elements from a larger set. And combinations is about choosing an unordered subset of R elements. So in the first case of permutations, the order matters, but in the case of combinations, the order does not matter. Let me start with a concrete example to explain this further. So suppose I have a club of 9 people, some kind of, let's say, discrete math club, and I want to choose a chair and a secretary, and I want them to be different. So I want one chair and one secretary, but the same person is not both of those. And how many ways of doing that is an example of a 2 permutation. So here the order matters. One person is chair and one person is secretary. On the other hand, if I have the same example, but now I have to form a subcommittee of 2 people, well, now the order does not matter. In the subcommittee, there is no such thing as the first member and the second member. There are just 2 members in there in any order what you want. And this is an example of a 2 combination. Okay, so the first example, the order matters, second does not matter. And these 2 are closely related, but different concepts, and they give you different answers. We'll start with the first one, permutations, which is easier to compute slightly. So let's continue the same problem. I have to find the number of ways of choosing 2 people. No, let me rephrase. I have to find the number of ways of choosing a chair and a secretary from a committee of 9, from a group of 9 people, and I want them to be different. So number of ways of choosing one chair and one secretary. And this is different from chair. Now we can use the same principles that we've been learning in the previous videos. There's an and, so I'm going to have to multiply. For the chair, I have 9 choices. For the secretary, now I can't pick the person who was the chair, so I have 8 choices. And so the total answer is 9 times 8. Now you might say, well, what if I choose the secretary first and the chair second? You will get exactly the same answer. Okay, so that's 2 permutations. That's an example of 2 permutation. Now what we're going to do is we're going to generalize the above technique and abstract it out and get a formula for, in general, picking R elements out of N elements. So the setup is I have a set of N elements where N is a natural number, positive. And I want to pick R different elements out of it. And I want to pick them one by one. So I'll pick the first element, then the second, then the third, then the fourth. That's what I mean by in order. And I want them to be different. So the element that I picked to be the first one is different from the one that I picked to be the second, which is different from the third, and so on. And so how many ways are there for me to do this, to make these choices? This is a recurring thing we'll see throughout this chapter is there's no theorem. We are doing tricks, that's all there is. But the way we'll do it is we'll see what happens in small examples, and then from that we'll extrapolate to the abstract version. So let me take the example of R equals 1. So when R is 1, I'm making one choice, and I have to choose between N elements. If I have N elements, I'm making one choice. How many ways are there to make the choice? The answer is N. Now suppose I make 2 choices. Then the first element I can pick in N ways because I can pick any of them. Now the second element cannot be the first element. So now I have one less choice for picking the second element, and so I'll get N times N minus 1. Let's go to 3. Now the first element can be any of the N elements. Once I make that choice, now I no longer have N elements, I have N minus 1 elements. So the second element has N minus 1 choices. Now the third cannot be either this one or that one. So I'm left with N minus 2. Let me do one more. And you can see the pattern, N minus 1, minus 2, minus 3. And so if I were to extrapolate out of this, if you have R, where R is just some integer, as R is just some natural number which is less than N, then the number of ways of picking R elements in order, which are different from each other, is n times n minus 1, n minus 2, and so on. And how many do I want? I want R of these. Okay, so I want R terms in there. And that's how I remember it. But let's say you want to be a little more specific and you want to ask yourself, where does this thing end? Now, when R is 2, you can see that it ends at 1. So this one you can say is 2 minus 1. If you see where this ends, it is 2 and 2 is 3 minus 1. Why am I writing it like this? Because these things are R minus 1. And in the first case, you get 1 minus 1, which is 0. So you can think of n as n minus 0. And so from this pattern, you can see that the last element here should be n minus R minus 1. So that is the answer. The number of ways of making an ordered list of R elements, of distinct R elements from a set of n elements is n times n minus 1 times n minus 2 dot dot dot. And the total number of such terms is R. But if you want to be a little more precise, you can also write this as n times n minus 1, n minus 2 dot dot dot, up to n minus R minus 1. Same thing. Both these products have exactly R elements. So that is the number of R permutations from n elements. We can stop here, but there is another way of expressing the same answer, and that is using factorials. A factorial is just a notation. So what is the definition of factorial? When n is a positive integer, n factorial is denoted n like that, and it's pronounced factorial. It's an exclamation mark, and it's n times n minus 1 times n minus 2 times all the way down to 1. Okay, so you don't stop anywhere. You go all the way down to 1. So now I can re-express the term above using factorials as follows. This is a trick. Again, you shouldn't expect yourself to have come up with this if you haven't seen this before. So what I'll do is I'll take n times n minus 1 times n minus 2, n minus, now I'll expand out the minus R minus 1 in there and make it minus R plus 1. So now I will draw a trick. I will multiply the numerator and denominator by n minus R factorial. Just a trick. There is no justification. And now I'll expand the n minus R factorial in the numerator. So you get n times n minus 1 times n minus 2. And the denominator, I'll keep it as it is. And now if you look at what has happened in the numerator, well, now it's just the product of all the terms from n all the way up to 1. And so that is just n factorial over n minus R factorial. And that is my answer. The number of ways of choosing a list of an ordered list of R different elements is n factorial over n minus R factorial. Now, before we move on to examples, one last thing I want to talk about is the thing of 0 factorial. It's a little unsatisfactory, but that's the thing that works. So I'll just give you what it is. You just have to remember this. In math, we also need 0 factorial. And 0 factorial is defined to be what? There's no rhyme and reason behind this. This definition works. It makes a lot of proofs work properly, and that's why we use this definition. It doesn't fit the above formula, but that's okay. This is how it's defined, period. The example we did way above, where you had 9 people, and then you had to choose 1 chair and 1 secretary. And this is different from the chair. And the number of ways of making these choices is 2 permutations. So I'll get 9 factorial over 9 minus 2 factorial, which is 9 factorial over 7 factorial. And now I'm going to expand both things out. So I'll get 9, 8, 7, 6, 5, 4, 3, 2, 1 over 7, 6, 5, 4, 3, 2, 1. And now you can see that 1 cancels, 2, 3, 4, 5, 7. All of these terms cancel, and all you're left with is 9 times 8, which is the answer we had in the beginning. So now this is just a very compact packaging of something that we already. One very common R permutation is the whole n permutation. So now this is the last example we'll do here. And say you have n elements, and you are asking what is the number of ways of ordering these n elements. This is a very practical problem. Let's say you have some books at home and you want to ask how many ways are there for you to order them in some way. In terms of R permutations, this is just n permutations because you are picking n elements in order. So this is nothing but n permutations. The only weird thing is your total set is also of size n, but that's okay. Of the size n set, you are picking an ordered list of size n. So you can think of this as n permutation. And now using the above formula, this is nothing but n factorial over n minus n factorial, which is n factorial over 0 factorial, which is just n factorial over 1. That is n factorial. So n factorial is the total number of ways of ordering a list of n elements. And you can see why this is the case. If I expand out n factorial, this is n times n minus 1 times n minus 2 times n minus 3. So all the way up to 1. And what's happening is I'm making an order. So I can say how many ways are there for me to pick the first element? That's n. Then that's taken care of. Then what should the second element be? So there are n minus 1 choices. Then what should the third element be? There are n minus 2 choices, and so on all the way up until I'm left with just one element, and then I just put it in the last place. Okay, so that's n permutations.